subtraction technically of 1 AFR point for everything over 100 load, everything that's under positive boost pressure. Now this method that I've taken of selecting everything in positive plus 100 engine load and adding and subtracting values, that may not be the ideal way to set up a low octane fuel map or a low octane timing map, but in my opinion, you don't really need to spend too much time on these maps, because if your tune is good, you'll almost never be utilizing them. So to spend more than a few seconds going into detail about how you want the low octane fuel and timing maps to look really seems like a waste of time in my opinion. All you want to do is worry about your high octane map being 8.5% safe, and the other minor percent of time that you encounter low octane maps, it's at least a moderate amount more conservative than your high octane map. So you don't worry about too much, at least I don't worry too much about these values that live in the low octane fuel map, so long as they do their job, and in the case of fuel, add some, in the case of timing, subtract some. So that's the general idea behind rescaling the engine load columns. You can rescale the RPM rows the same exact way. So just to give you a quick example, let's say we needed to add the 8,000 RPM row here, because let's say we've got a nice set of cams, nice valve train upgrade, and we want to rev this guy to 8 grand, and we want to be able to tune it when it's up there. So if that's the case, you can probably find pretty simply 2 rows that look identical or almost identical, and it just so happens that the 500 and 1000 do happen to be identical. So that makes it really easy for us. We can basically just shift everything up and kill off that 500 value and set up 8000 at the bottom. And of course, when we do that, we've basically got to move the rest of the map as well, because it doesn't get moved on its own. And now that we've got this extra line down here at the bottom for 8,000 RPM, we can begin to tune that. Or we can possibly maybe take away 0.1 AFR just to go a little bit richer than it was at 7,500. So in just a few keystrokes and a few copy and paste commands, we've basically redefined the entire structure of this fuel map and given access to the tuner to a whole new set of tunable cells. So all these highlighted cells are cells that just did not exist in the stock form, and by having access to them and using them to your advantage, you'll be able to obtain a more precise tune with a little bit better resolution. Now you can also do things a little bit more advanced than just shifting things left and right, up and down. Is you can get even more specific in terms of the cells that you want to put into these columns. So in the case where we go from 50 to 60 to 70 to 80 to 90 to 100, it doesn't always seem appropriate, depending on how much space you have. Like I said, particularly if you've got an older Evo 8, where your space is very limited, but to have 6 cells to deal with load between 50 and 100 is pretty excessive, and you can tell that there's not really too many changes that go on in between these values. Now I'm not going to suggest we go directly from 50 to 100, but we may be able to jump from 50 to 70 to 90 to 100 and eliminate the 60 and the 80 columns. Because you know what, they're not necessarily going to be required to have the car run 100% perfectly or have the car run properly. Having the ECU interpolate for the 60 and 70 by way of having this data in the 50 and this data in the 70 and this data in the 90, should be sufficient. And I haven't encountered any problems with drivability. I've done this on all kinds of Evos, 8s, 9s, and so on, where I've basically reduced this entire 14.7 area of the map, which on the original fuel map is quite large, and regained a lot of this space on the other side of the map for actual wide open throttle tunability's sake. So I've been able to condense this down considerably when you get into some more intricate scalings. So you can do something along those lines. You can omit the 60, the 80. You can add, if in particular, it may just so happen that if for a majority of your wide open throttle time, let's say for example, a majority of your time from between 4,000 and 6,000 RPM, you're experiencing 270 load. Well, 270 is going to be right in between what we have in our map here for editable values, directly in between 260 and 280. So you'll always have an interpolated value for your 270, and you won't have any direct control over how much timing is run. You'll have to edit two values for every one that you want to change. So if that's the case and you happen to have a need for a 270 column here, that would be an example of why you would want to kick one off of the lower end, move everything down a spot, and add a 270 column. So why don't we do that now just for demonstrative purposes. So we'll take 70 to 260 and we'll bump it down. And now we've got two 260s. We'll make the second one a 270. And we'll take all of the cells that were beneath the 70 to 260 that we just shifted, and we'll shift them as well. And now we basically have duplicated data here. So whatever we had in 260, we now also have in 270. But when you go out and tune in data log, if you've got 270 being your predominant load value that you're logging between 4 and 6,000, now you really only have to worry predominantly or initially about what's in this column without spending too much time worrying about what's in those neighboring columns. And there's really not any additional benefit in going any more specific than maybe an increment of 10 here. Load fluctuates pretty quickly, so it's not like you're going to benefit out of adding a 265 in between your 260 and your 270. To have an entire column in use for just a load difference of only 5 load, that's a little bit excessive in terms of how much resolution you need in your maps. But it's not unreasonable to utilize one or two areas where you just want that one extra column in order to gain a little bit more control over what goes on. So all these things apply for both the fuel and the timing maps. They apply for any other maps really that utilize a scaling that's adjustable. So if you're controlling boosts with the stock ECU, and we look at our baseline wastegate duty cycle, one of the things that I've done since I use the stock boost solenoid is I've noticed that the RPM scale on the baseline wastegate duty cycle, it gets a little more specific than I need it to, especially having a bigger turbo than stock. It really doesn't do me any good to change wastegate duty cycle 3 or 4 times just in between 2,000 and 2,750 RPM. Really, only 1 or 2 values will do just fine there. So I can probably, just to give you a quick visual of what this might look like, I can probably rescale this guy in a matter of a few seconds from 1,000 to 2,000 to 3,000. And then maybe now I'd like to use 500 RPM increments and maybe even 250 RPM increments, where boost is really starting to pick up now. And that's when I really need to get specific as far as how much wastegate duty cycle I'm utilizing. But when you do something like this, this is a little bit easier to worry about because you only have a 2D table where you don't have to shift things necessarily as much or at all. If you're tuning from scratch, if you're tuning wastegate duty cycle from scratch, you may just set these guys all to 20 or to 0, to 10, and just start from scratch there. I'll just finish entering values in here just so you can get an idea. So this might be a more useful scaling for someone who's got a little bit bigger turbo. Maybe it spools up a little bit later than stock, and they want to rev it a little bit higher. You might get more benefit out of having your resolution not in the 2000, 2200 RPM range like the stock scaling does on wastegate duty cycle, but in the upper end, in the mid range here, where we hit 3750 to 4750, where we want a lot of our precise control to control boost spikes and so on. So this concept of rescaling tables, it applies to pretty much every 2D or 3D table in EcuFlash. So it's a good skill to have, and it's good to use, like I said, especially when you don't have much real estate here. So hopefully you have an idea now of how exactly to rescale an axis and why you would do so, and hopefully you can utilize EcuFlash's interpolate functions if necessary to kind of round off the newly created areas of your maps once you're done rescaling.